We're going to start with number 4 here, with these two situations, the pulley suspended before and after. And I'm going to grab this so that I don't have to try to redraw. Does anyone just off the top of their head know what's a pulley's job? To lessen the force. That would probably be most people's first instinct, is that it's to lessen the force. Make you, what'd you say? No, do a try. Equalize the force. It's not a bad thing. Make it easier. It's a pulley's job is to change the direction of the force. That's what its job really is. In using multiple pulleys and multiple strings and things, we can make less force needed. But its main job is just change the direction of the force. So like in case A here, a force that is on one side of the pulley that's going down or going up, as it goes around the other side of the pulley, will be going down. If the rope extended off to the side like this, it would change a vertical force into a horizontal force. So it's a pulley's main job is to change the direction of the force. That's what it does. And that's kind of a weird thing to first think about, but now you know. Maybe it's less weird. So I'm going to do my force diagram, which is the part that would be counting for my Y. And I'm going to do them side by side because we have two situations, so we need two diagrams here. I'm going to have a weight down here, the same weight down. How do I know that those two weights are the same? Okay, the same M, right? And I'm assuming they're on the same planet. Yeah, because it's the planet and how much mass something has that makes its weight. Here, I'm going to have FT, and I'm going to call that FTA for tension in situation A. And now, something you may not know, but here's a good time to realize it. As long as I don't have friction on my pulley, the tension is the same throughout my whole cord. So if I put a tension of FTA on the left-hand cord here, that same tension's on the right-hand cord. Which leaves me over here with just one cord we'll call FTB. That's a B. Well, I'm only doing the force diagram for the block. If I was doing it for the cord or for how much do I have to pull or something, then yes, I do, but I might do another one. We'll look at that when we look at systems. All right, which will be like 2 topics from now, next week. And I look at this and I think, oh, wait a minute. I have a feeling that FTB is going to equal FG. Do you guys see how I get that feeling? And I look over here and I say, oh, FTA and FTA combined are going to equal FG. Right? So what do I think, how do I think FTA compares to FTB? Double, half, whichever way you go. But let's see if that's true. So my gut is telling me the tension in situation B is probably twice as much as the tension in situation A. If you can't see that, that's fine. We'll prove it mathematically. But if you can see that, that can help you on the way down the road. So let's now do our free bodies. I'm going to kind of split this in half here and do A and B on either side. I don't have anything in the X direction, so I don't really need my X and Y. So here, I have FG down. Very repetitive here, I know. But as we get to, we do more complicated ones, being in this habit will help you. Even these ones you may not be as big a help on. Right? Good. I'm going to do A on this side and B on this side, and guess what? It would be like the identical same free bodies, right? So I would just draw them again. I'm going to skip drawing them again if you don't mind. No, I'll draw them again. Just because I'm trying to mimic for you. FG. This is where, like, if you were actually doing this on a test, I would not expect you to draw these same diagrams 3 times. So peaceful, just drawing the same thing. And now I do the sum of my forces for B equals FAB. And I'd have, which way do you guys want to call positive? Up. So I'd have FTB minus FG equals M times 0. So I'd have FTB equals FG. And then over here, same thing, but for situation A. And we'll call up positive again. I have FTA plus FTA minus FG equals M times 0. That's kind of a little check to do. I've got 3 arrows up here. Do I have 3 terms on my left-hand side? Yay. 2 arrows, 2 terms. Kind of a way to check that you didn't forget anything. Yeah. And then, so in my mathematics, to simplify, I'm going to have 2 times FTA equals FG. Yes? Everyone see how I got there? I'm told my FTA is 88.5 newtons. So I have 2 times 88.5 newtons. That's N equals F sub G. Oh. So F TB equals 2 times 88.5 newtons. Let's see, 80 times 2 is 160. 8.5 times 2 is 17. So I get 177 newtons. Feel free to use your calculator if you need to. Let's see if I got it right. Well, that's what that says, right? 2 times. But yeah, yeah, multiply by 2 in my head. I did it right Monday morning. Alright, so we're going to do number 5 here. And again, I'm going to cheat and forgot my drawing. Of our tightrope walker, going between the 2 with that sag in it. Alright. So... And... Problem number 5. Alright, so let's see. Force. Now, this is one thing that you may not have known, and hopefully you realize after that last problem, that if there's one continuous wire, it has one tension. So this would actually be your, sorry, that F got a little carried away on itself. That would be your force diagram on that, where you've got the walker's weight down and you have the 2 tension, which is really the same tension, just pulling in either direction on the point that she's at. the only thing that would be different if she wasn't is that we wouldn't have the 10-degree angle at either end. You'd have different angles at either end if you're not the dead center. So guess where I'm always going to make your person? Dead center. If you're in honors, guess where they'd be? Probably not dead center. They'd be to the left, to the right. And so, like the, well, it's just the difference in levels, but you have one like that. You've got this one with the traffic light, which is really the exact same problem, except we've shifted it over to the left a little bit. So that you don't have the same tension, you don't have the same thing. So, here's, and maybe we'll get to that one. So here's there's the force diagram. The free body, very similar. We have T, F sub T, and F sub T, and we have the weight down, F sub T. So that's what you would have for the free body. Now, but I have forces now that aren't strictly X or Y, so I need to do the components, and I'm told that this angle is 10 degrees. I think that's right. Let's see. Yeah, 10 degrees. And I have the same type situation over here. 10 degrees. That's going to give me a horizontal component in each case, and a vertical component in each case. My vertical component, like over here, will be FT. Let's see, it's opposite the angle, so what trig function? Sine, or sin, either way you want to say it, 10 degrees. And then, same thing over here, I'm opposite, so I FT, sine, 10 degrees. I remember them because you have to look across to see the signs. And then, next to it would be FT, cosine 10 degrees, and FT, cosine 10 degrees. And I think that about takes us up to lunch, right? Yeah. Huh? Yeah, so we'll pause here. All right, so let's continue on number 5 here. All right, so we've got our main free body done here. And now we're going to just do our X and Y free body. So we, of course, need our big dot. In the X direction, I've got 2 forces. FT cosine 10 degrees and FT cosine 10 degrees. In the Y direction, I have 3 forces. F sub G. These 2 up. Each one being FT sine 10 degrees. Sine 10 degrees. So those would be my individual free bodies of X and Y. Now on the X side, I could continue on, but all I'd prove is that FT equals FT. See how those 2 would equal each other? And then the signs would cancel out. So I'm going to continue more on my Y side. That looks more interesting. Some of the forces in the Y, M-A-Y. And I have F-T, assuming up is positive again. Three forces, 3 terms on the left. And my acceleration is 0 again, so m times 0 is 0. So I'll leave that open. So rearranging this, I get 2 times ft sine 10 degrees equals f sub g. Put parentheses around that. Right? Yes? So, which direction I pick the arrow to go? Yeah, exactly. Let's see, what do they tell me? They tell me her mass, right? So, and I'm looking for ft. So personally, I'm gonna remember that f sub g is the mass times the gravitational field strength, mg, right, from my equation sheet. And I'm going to rearrange this to get ft equals fg, which is mg, over 2 times sine of 10. And then I'm just going to substitute in ft, what was mine, 60 kilograms times 9.80 newtons per kilogram over, excuse me, 2 sine 10 degrees. And then I do my math. Let's see. Parentheses, oops. 60 times 9.8 divided by 2 times sine of 10. I'm going to do parentheses again just because I always freak out about order of operations. That is, I realized from my equation sheet, the weight of something is its mass times the gravitational field, right? And on the Earth, we take it as 9.8 newtons per kilogram. And I hit enter on that, and I get 1,693, rounding that to 1,690. 1,690 newtons, because kilograms times newtons, kilograms times newtons per kilogram is newtons. Let's see if that's right. Yep. Except no weight. You have a force instead. Yep. Right. Got it. Exactly. All right, so we're going to do number 3. The traffic light suspended from the cables. 14.2 kilogram traffic lights. All right, so there's my diagram so that I can do. So this is what did I say? Number 3. So there's my diagram so I can do mine. And here I'm going to label this. I'm going to be lazy. Call that F to the left. Call that F to the right. They're tensions, but I could label them, you know. And then down on here is, of course, wait. They're not one cable because they're at different angles. Think about it, if it was one cable, this would slide to the middle, wouldn't it? Yeah. So they're 2 separate cables joined together there. Now, and that actually brings up a good case. Let's say that we don't know if it's one cable or 2 cables, and intuitively we look at it and we can't tell. Well, the safety would be to label them as different forces and then prove that they're the same. Alright? So it's actually safer to label them left and right or 1 and 2, and then come up and figure out, oh, wait a minute, 1 equals 2. Like in the last problem, if we'd done the x side of it, we would have seen that the two tensions were the same. So it would actually have been probably better practice to do it as 2. So that's my force diagram. That's the part I grade for your y. Now on to the how. We have our big center dot. And we have the force of the weight down. F to the right that way. Force to the left that way. And those are in 2 dimensions, so I need to divide them into their components. This one, I believe, let's see, what angle is this one at? This one's at 30 degrees. And then my left-hand one is at 60 degrees. Remember your geometry, opposite, interior angles, or something like that. And then you have you break them into these components, horizontal and vertical. And since they're across, like this side would be FR sine 30 degrees, while this other red one is FL sine 30 degrees. Oh, 60, thank you. Because I was wrong. Good catch, Bob. And then FL cosine 60 degrees. FL cosine. That looks horrible. FR, wow. What did I have for lunch? I just lose my mind. FR cosine 30 degrees. Good thing you guys are paying attention. Yeah, that looks right, even with all my attempts to make it wrong. So now we go with the x direction here. We got 2 forces in the x direction. FR cosine 30 degrees and FL cosine 60 degrees. Yep. And then we do the y direction here. And how many forces do we have in the y direction? 3. We have the weight. And then we have these 2. F R sine 30 degrees and FL sine 60 degrees. Huh? Well, now I'm organized to do my math in straight X and Y. You're right. I could have skipped all of this. I could have, from this point, said, you know what? FG plus FR plus FL adds up to 0 because I have no acceleration. And if we were doing this as, say, in AP Physics 1, that's how I would expect you to do it. And then you'd realize, you know, how the interior angles worked and everything like that. Chances are, if you do that, in this one it's not true, but in a lot of them, it wouldn't be a right triangle. And so you'd have to do some non-right triangle trick, which is fine, you can do. Not a worry. But my guess is most of you are not comfortable with it. So instead, we do some extra steps here of breaking it into X and Y, because my hope is that you guys are comfortable with linear and straightforward algebra. All right, so trying to get the trig, even the right-hand angle trig, which you guys are less comfortable with, out of the way before we do the algebra. Just trying to separate the math out for you guys to make it more straightforward. But it does take more steps. You're completely right. The other way, I'd be done with this in maybe 3 steps. So if you see the other way, great, do it. And that's partially why you're only being graded on the free body, the force diagram, not the free bodies. Except that they need to exist, at least one of the ones for part of your outgrade. So, negative FL cosine 60 degrees plus FR cosine 30 degrees equals M times 0. So I could go to the next step here. FR cosine 30 degrees equals FL cosine 60 degrees. But I really can't go any further on that side, right? Because I have one equation but 2 unknowns. Out of luck. So maybe I can make some progress on the y side here. And so I have FL sine 60 plus FR sine 30 minus FG equals M times 0. I then mathematically go FL sine 60 plus FR sine 30 equals FG. But again, now I'm a little bit stuck because I'm, again, one equation, one unknown. I know FG, that's the mass times little g, and I know the mass of little g, right? In the beginning, I know it's on Earth, and I think I'm told the mass of the stoplight. But I still don't know FL and FR. So you could do this algebraically. We could also probably use Wolfram to solve it. Yeah, that little thing that can solve basically any math problem you give it. But let's try Wolfram on this. Because the one thing I don't want to put in there, though, is all these cosines and sines. So I'm going to kind of write it down here in how I would put it into Wolfram. I'm going to, rather than f sub r, I'm going to use r. And then rather than cosine of 30, I'm going to get what the number cosine of 30 is, which is 0.866025. 0.866, that's a 6, 025 equals, I'm going to call that L. Cosine of 60, I happen to know off the top of my head, 0.5, I hope. Yep. Oops. And then I'm going to also over here have L. Sine of 60 is 0.866025. You can check that if you'd like. Plus R sine of 30, 0.5 equals M. For M for me is 14.2 times 9.8. So I've left off units and everything like that that would cause me to enter it into Wolfram incorrectly. And now what I'm going to do is I'm going to open up Wolfram. See how I have my equal sign here? And then I have mg. Well, I substituted for m and I substituted for g. 14.2 is the mass of mine. No, that would be right here where on my problem it says a 14.2 kilogram Whenever I see kilograms, think mass or inertia. That's okay. What other number? Oh, that's because we live on the planet Earth? That's okay. We know your handwriting is better than mine. Experienced that last class. Alright, so, wow, we're going. It is definitely Monday afternoon. So I'm going to put in this equation. R times 0.866. Shouldn't. 0.25 equals L times 0.5. So I have, that's my equation for my x side I put in. Now I put in comma, and then I put in my equation from the right-hand side. I'm just typing in my equation. I do a comma to separate them, to tell the computer that they're two separate equations. That was the one from the right-hand, from the x side. This in black is what I've prepared to put into Wolfram. I'm working on putting them both in at the same time. Yep, I separate them by a comma. I did comma space. Once I have them in, I hit equal. It's not liking L. So I'm going to replace this with X and Y. Yeah, I did it the other way. I don't know why I did like that, but it did like X and Y, so that's good. And it tells me that X, which is my R, it tells me that's 69.58, and my Y, which is my L, is 120.5, so. Huh? I don't know. Depends. Depends on your phone. So what that has told me is that R is a 69.6, and L is 120. So I put him in a little. When I looked at what? I looked where it said solution here. So I'm going to try them and see if they work.